what is NodeMCU? Okay, like NodeMCU, like it is a open source. It's a low cost open source IoT platform, Internet of Things platform, which has the microcontroller as well as the ESP8266 Wi-Fi module. Okay, so it has the microcontroller unit plus the hardware, the firmware plus hardware based on ESP8266. So like if you it was so popular because you could use this ESP8266 Wi-Fi module with Arduino. So Arduino is an IDE like where everything is pre-written, like they have simplified the registers, so no need to worry about the registers, like everything is internal. So you could concentrate only on the application part. Okay, for example, you just take UART, universal asynchronous receiver transmitter. You could implement UART within 2 or 3 lines of code. Whereas when you want to write the same code on say on any compilers, other compilers like the Kale compilers or the write compiler or MPLAB IDE, you have to configure those UART registers properly, the baud rate and everything you have to take care, and you have to you have to do it. You have to do it by yourself. Okay, and you have to write the code for like around 20 to 30 lines of code for transmit and for receive. Whereas in Arduino IDE, like everything is inbuilt. Like you have, but when you customize the board, when you have your own board, when you have a custom board, then it may become quite complex. Whereas if you have the basic boards which was supported by Arduino IDE, like the Arduino Uno or the Arduino Mega version or the NodeMCU or any ESP32 version, which comes with the board support manager, board support package, like where you no need to worry about the registers. Everything is pre-written. You just call this, you just install this installation manager. You just call this so that you could use the library files. Okay, you just library files for printing, for UART or for digital read or digital write. Okay, so for ADC, so everything, the code will be very easier for you, where you could concentrate only on the application part. Okay, so that's why it is so popular, like for implementing the IoT applications or for implementing the protocol like TCP/IP or MQTT protocol or any web server protocols. It is very easy for you to manage the code. Okay, so coming to the IO devices, like if you take the NodeMCU pin details. Okay, this is the development board, NodeMCU version 1.0. Like you have A0, like A0 for analog pins, where it could accept the analog signals. Okay, so the microcontroller can accept only the digital pins. So if you want to directly interface the analog signals, then it has to be interfaced with the ADC. Okay, so analog to digital converter. So this has an inbuilt ADC, like where it has A0 is the where A0 you could give the analog pins, and you have GPIO for general purpose input and output. It is also multiplexed. It could be used as a GPIO or the specialized pins, like the master out, slave in, chip select, and MISO, master and slave out, and S clock, serial clock for SPI interface, and ground and 3.3 volt for the power supply, and enable pin and reset pin, again on ground VIN for power input. Okay, so you have GPIO or TXD or RXD, which is used for serial communication. So it has two UARTs. So receiver and transmitter TXT 0 and TXT RXD 0. Okay, so TXD 2 3, like totally of 3 UARTs, like TXD 1 and TXD 2 and RXD 2, so that it could be interfaced with the other serial communication devices using the serial mode. Like the serial communication devices may be like it may be a GPS device, or it may be any device which supports TTL format. Okay, the output will be in TTL format, and it also has the flash, like digital pins, like from D0 to D4, and like user awake. Okay, for sleep mode. So these are all the pins These are the pins available on NodeMCU. So the chip contains of ESP8266 is 32-bit RISC CPU, reduced instruction set computers, and it's a 32-bit CPU. It could operate at about 80 megahertz. So it has an instruction 64 kilobit of instruction RAM and 96 kilobyte of data RAM. Okay, and external flash is 512 KB and like 16 GPIO pins. It has 16 GPIO pins with SPI interface and I2C interface, I2S interface for audio interface, and UART on dedicated pins. Okay, and 10-bit ADC, one 10-bit ADC analog to digital converter is there, and 3 PWM pulse width modulation for motor controls. Okay, and it supports Wi-Fi. It supports onboard Wi-Fi with IEEE 802.11. If you check the NodeMCU, the same similar kind of another board is there, ESP32, which has Wi-Fi plus Bluetooth. Okay, whereas here, like it has the NodeMCU has ESP8266 plus the MCU. Okay, so ESP66 plus the node. So these are the chipset details of ESP8266. 32. I repeat, it's a 32-bit RISC CPU, RISC microcontroller, like reduced instruction set computers. Okay, from the manufacturer of Tensilica extensor at 80 megahertz, which runs at 80 megahertz, and 64 KB of kilobytes of instruction RAM and 96 kilobits of data RAM. And it has Wi-Fi interface, like which supports authentication or open networks, both authentication as well as open networks, and it has 16 GPIO pins, which has SPI, I2C, and I2S interfaces with DMA direct memory access and UART, and one 10-bit ADC and 3 PWM, 3 pulse width modulation. Okay. So softwares, like it officially supports the NodeMCU firmware called Lua, and it also supports MicroPython. You could also download the MicroPython and you could write the program on the MicroPython. And Esprino, like it supports Esprino, like you could flash the Esprino firmware on the NodeMCU board, which supports JavaScripting, JavaScripting based codes. And Arduino, it also supports the Arduino codes. And official ESP is A8266 SDK, software development kits it supports, and the compilers from Adafruit. Okay, software from Adafruit, it supports the softwares from the Adafruit. Adafruit is a company which manufactures like Arduino boards and the sensors. So these are the softwares supported, like the official NodeMCU firmware, the MicroPython, the Esprino, Arduino, and official ESP8266 SDK. So you have to download the Arduino software. I'll show you how to download this Arduino software. Okay, so you just go for Google. Okay, you search for Arduino, like you could download from the Arduino website. Okay, you just click arduino.cc, and you have an option to download Windows. Okay, zip file. You just download this zip file and you install this software, Arduino IDE. After that, you just go for Google and search for NodeMCU JSON file. Okay, JSON link. So you will get JSON link. So you search for NodeMCU JSON link. You will get the link in this format. You click this first link, okay, ESP8266. So if you scroll down, like you have Arduino on ESP8266, okay, using board manager, you have the boards manager link here. You just copy this link. Okay, you just copy this link. You open Arduino IDE. Okay, go for file, click preferences, and you have in additional boards manager URLs, you have to click this one and you have to paste this link. Okay, you have to paste this one. Once you paste this one and click OK, you just go for tools. Okay, so you will get it on the boards. Okay, preferences. Once you tools, you go for board manager. click for boards manager. Okay, you click for the boards manager. Here you have to search for, I have already installed this one, so I'll remove this one. Like if you check for ESP 8266, okay, ESP 8266, I have already installed this one, so I just click remove. Okay, so you will get this one, click install. Okay, once you put the JSON link there, like you just go for the boards manager and click install here. Okay, so once you click install, this will install this ESP8266 board. Okay, it will install this ESP8266 board. Once it is done, you just close this one, like you go for file, then you just go for the you go for sketch examples. You could check for the example sketch. Okay, examples, like you could see for, you could check for the NodeMCU. So you just go for tools and you check for the NodeMCU boards, like you choose for the ESP32 boards, choose NodeMCU 1.0 ESP12E module. Okay, and then you just go for examples, like you will get the example code for ESP8266. Okay, you will get the example code for ESP8266, like for wire, for EEPROM, ESP8266, blink. Okay, for blink the LED, you just choose blink LED, so you will get a blinking LED code here. Examples, you just go for ESP8266, blink, hold timeout without delay, call SDK functions, check flash config. Okay, these are all the example codes for I2S input, I2S transmit. Okay, so once you install this board support manage boards, installing boards manager, and then like you could use the Arduino IDE for ESP8266 module. Okay, and the next is like ESP8266. It was supported by the ESP8266 open source community. It's a single board microcontroller, like operating system like XTOS is there, and CPU ESP8266, memory 120 kilobytes, storage 4 bytes, and power is USB. Okay, you could use the website NodeMCU.com and NodeMCU readthedocs.io. Okay, these are the websites. Like you click NodeMCU.com, like you could check. I just open the website NodeMCU.com. Okay, so this website has like you choose the English website. There's an option to choose English. So where you have like the examples to connect to the wireless network, Arduino like IO access, HTTP client, HTTP server, pulse width example for pulse width modulation and blinking LED. Okay, and bootstrap, user timer to repeat, interfacing with sensors, telnet server. So these are the few examples. Like you have a lot of features. You could check for the development kit. Okay. Okay, so this is the GPIO. Like this is the pin details, like which I have already explained, like 5 volt power, 3.3 volt ground, GPIO. This is for SPI interface, UART interface, SPI. Okay, ISP and I2C. and key system and ADC and for reserved memory. So coming to the Arduino, like you Arduino, like you have sketch, like where you could write the programs, and like you have option to declare global variables on the top, as like C program, like you could declare the global variables on the top, and it has two, like one is the setup and another is the loop. Whenever you create a new Arduino program, Arduino sketch, okay, like you have a setup function which runs only once at the beginning. Okay, so all the initialization codes you could write inside the setup functions, whereas loop is the one which runs repeatedly after setup. So if you have the while loop as like the void main program, like where inside, if you want to configure any while loop inside the void program, that code could be placed on this loop, okay, which will run repeatedly after setup. And so the global variable, like you could declare for the int LED pin equal to 13, it means LED connected to the control pin 13, okay. And int a sensor is set up a sensor to an analog pin 0. State pin is low, use is called the state of a pin, okay. So these are all the global variables. Like pin mode, it has pin mode to set up pin as input or an output pin, and serial begin is just to configure the serial communication, okay, just to configure the serial communication with the computer. Like you could connect with this communication with the computer, like begin serial.begin. And like, so if pin mode is LED pin is output, it means whatever the pin which is declared to LED pin is as an output pin. So the LED pin you have to declare as what port, at what pin number it has been connected. And serial port 9600 means it sends the data at 9600 baud rate. Okay, it transmits the data at 9600 baud rate. The other functions like digital write, you have functions like digital write, where you set a digital pin high or low, okay, or digital read to read a digital pin state, and analog read to read an analog pin, and an analog write to write an analog pin. Okay, so for a pulse width, for a PWM. So digital read to write a digital pin, read to read the digital status of the digital pin, and delay is used to wait an amount of time, and milliseconds to get the current time. Okay, millis is to get the current time. So delay, wait an amount of time. So these are the simple functions. So let's this is the code for blinking an LED. I have 3 LEDs like D3, D4, D5, and I will like I set up just begin a board at 9600. Like, so no need of serial.begin, like it is, we are not going to print it on UART. So pin mode is output. So all the 3 LEDs are output pin. So it is connected to D3, D4 and D5. Okay. So D3, D4 and D5. D3, D4 and D5 is here, like D3, D4 and D5. Okay. GPIO was 0, GPIO was 0, 2, and GPIO 14. Okay. So it is connected to D3, D4 and D5. And void loop, like digital write, we are making this high, LED1 high, LED2 has high, LED3 is high. We make a delay in milliseconds, like 1000 milliseconds, and then we make it low. And let us check for the output. Okay, I just open the Arduino IDE. Just go for file, go for new. Okay, I just click this to get the new sketch. Okay, so I'm going to configure the board. I'm going to check, like go for tools, and it is connected to COM13. I just checked for the device manager to where the board is connected, device manager. So it is connected to the COM port COM13. Okay, so I checked for the board, like the board is NodeMCU 1.0 ESP 12E module. Okay, I have to choose this one. Okay, and then like for blink LED. Okay, so like I just go for this line. Okay, and I'm going to declare int of LED1. This is the LED1 which is connected to D3. Okay, so I just increase the size. Okay, int LED2. So I'm counting the so I have counted 3 LEDs. So int, okay, LED3 called D5. Okay, so set the global variables here, like you could all the initialization code you could paste it here. So pin mode, okay, so it has capitalization, so you have to check for the capitalization here, like you have to use the correct one. LED1 is of output. Okay, this is output. Okay, so LED2 and LED3. So while loop. So I just tried, okay, digital write, digital W should be on caps, digital write of LED1 and high. Okay, so I just copy this one and I paste it for 3, 2 and 3, 2 and 3. Okay, and delay, like I just give delay of 1000 milliseconds, and I just copy this and I make this is low. Okay, low should be capital. Okay, and I just give a delay of 1000 milliseconds. Okay, I LED blink, I say this code as LED blink. Okay, compile this one. For compiling, you have to click here, this compile the sketch. Okay, and it displays on the window here. Okay, it is taking some time. So it's getting compiled now. Okay, once the compilation is done, so I zoom out to show this output. Okay, so compilation is done. Upload to program the click upload. So I'll show you the output here, like okay, so it is writing, currently it is writing here, it is writing to the board. So the percentage it's showing down, like 83%, 91% is completed, 100% is completed. Okay, so once it's done, I'll show you the output. Like I have the board connected, like I'll explain you this. This is the NodeMCU. Okay, this is the NodeMCU, which I have connected to D0, like D4, D5, D3, D4, D5. Okay, I have connected this LED to D3, D4, and D5. Okay, so I just put a code for blinking LED. So for blinking LED, like I have, so I have first declare this pin as LED1, LED2, LED3 as D3, D4, and D5. And pin mode is to set whether it is an input or output. So pin mode, I have configured this LED1, LED2, LED3 as output pin. And this loop setup is to put the initialization code, which will run only once. Whereas loop, this will run again and again. Okay. So digital write of LED high. Okay, this will first, it will blink high and then it's low. Okay, and then it's low. So this is the program for LED blinking. Let's go for the serial port. Okay, let's go for the serial port. The serial port is very simple, like so I just go for create a new file here, new. Okay, new sketch. So I take this setup no declaration here, like I just put serial. Okay, serial, S should be of capital, serial dot begin. Okay, you set the baud rate as 9600 baud rate, and on the loop, like I'm just going to print. Okay, I'm just going to print serial dot print. Okay, for new line, this is Pantech solutions. Okay, so I just print this one. I just leave a delay of 1000. Okay, 1000 milliseconds. So this will print it continuously. Like I just say this as UART. Okay, compile this program. So I'm just going to compile this program. For compiling this program, this you have to click here. Okay, so this will compile the sketch. Okay, so as like the 8051, the PIC, or the LPC 4088, it does not have any registers. Like everything is done internally. Okay, you could concentrate on the application part, but when you have a custom board, then definitely like you have to go through the registers, like you have to go through the other compilers. So once the compiling sketch is done, currently it is under process. Okay, so okay, once the compilation is done, and then the next option is upload. Okay, you just click upload. So this will upload the board. Okay, upload the process. Once okay, now it is writing, like it is writing 7%, 15%, 23%. Currently it is programming the memory 38% and 46%. Okay, okay, once the programming is done, then you could open the XCT. You could also open here on tools like serial monitor, right? Serial monitor. You could check, like you could see the Pantech solutions is printed on the serial terminal. Else, you could close this one and you could open the X-CTU. Okay, X-CTU. Like you could choose the COM13. Okay, you could choose the COM13. Show hex. Okay, it first change the baud rate as 9600 baud rate and check for the terminal. Okay, clear screen. So you could check hide hex. Okay, so Pantech solutions is printed on the next line. Okay, so I'll show you the board. Like the board is pointed here. Okay, the board is pointed here. Like it is accessed through the same USB port, USB to serial converter. So this is an example for UART. So let's go for a switch and LED interface. Okay, switch and LED interface. I just close this program. Serial begin for baud rate 9600. Whatever the baud rate you want, you could configure the baud rate here, and you could put in this program like serial print and for new Pantech solutions. Okay, double quotes. You just give whatever the thing which you have. Whatever the thing you want, you could. This is demo. Okay, so you could compile this one and you could download this program. It will work. So I just compile this one. Currently it is compiling. I just close this XCTU software. Okay. Okay, and I upload this program. So now once the program it is okay, so it's currently it's programming. Like if you want to see the programming status, it's currently it is 30% now. Okay, okay, the programming is done. So you go for tools, serial monitor. So it will print this is demo. Okay, this is demo. So now let us go for the switch interface. I just go for file, new sketch. Okay. Okay. So I declare the uh, switch like I have 3 LEDs and 3 switch here. So I put a constant, okay, int. So constant won't change. So button pin, okay. So it's of button, it's of button pin, okay. Pin 1 is D naught. So it is connected to D naught. So I just copy this one D naught, pin 2 and 3. I have connected 3 switches. So D naught, D1 and D2. Okay. And I just copy this one LED pin. Okay. LED like LED pin 1 is connected to D3. Okay, D3, D4 and D5. Okay, pin 3 and this is pin 2, D3, D4 and D5. So setup, like initially, like we put button state as okay. So I will configure this as pin mode, like pin mode of LED pin 1. Its output is output. So I just copy this one. This is pin 2 and this is pin 3. Okay, pin 3. So I just copy this and the button is input. Okay, button pin 1. Input. I just copy this and paste this one. Button 2 and 3. Button pin 2 and 3. Okay. This is for the setup codes. Okay. So this is LED switch. I rename this as LED switch. So now coming to the loop. Okay. Coming to the loop. So button state. So we have to declare a button state here, like int button state 1 equal to 0. This is for 2 and this is for 3. Okay. So coming to the while loop, like we are going to read the button state first. We are going to read the button pin. So that's the button state, like the button state 1. I just copy this button state 1. Okay. Button state 1. Digital read of, or should be caps. Okay. Digital read of the button pin 1. Okay. So I just put if button state 1 is high, okay, equals high, then else, okay, if button state 1 is high, then you just write digital write of LED pin 1 high. else digital write LED pin 1 is low. So else okay. So let's check for this one, like I just give auto format tools, go for auto format. Okay, I just copy this one. Okay, so this loop, okay, this, if this loop ends here, this loop ends here, okay, and this for loop. Let me check once, like I compile this program, let me check for error. So currently we have put only for one switch. Okay, so compiling is done. I have uploaded this program. So it's content to COM13 and it's getting uploaded. Okay, I have counted only one. I have read only the status of the one switch, one push button, and then we have write into one LED. Okay, so let's check now. So once the programming is done, I'll go for the demo. Okay, so I check. Okay, okay. So these two pins are not working. Okay, these two pins are not working. This is working. Okay, I'll show you here, like this is working, these two pins are not working. Okay, so I just copy the code. I just copy this code, paste it here. This is as button pin 2. Okay, this is button state 2. Okay, put LED pin 2. Okay, this is LED pin 2, and copy again. Okay, this is button state 3, button pin 3. Okay, this is LED pin 3. Okay, save the program and compile the program. Okay, I'm just compiling this program now, and I just upload this program. Okay, so it is uploaded. It's currently writing 8%, 16%, okay, 25%, 33, 41%, 50%. So it is getting uploaded now. Now I show the demo here, like if I check now, okay, if I check this now, okay, so all the three LEDs, like it's glowing, like we could able to push this button. Okay, so I'll explain the code one more time. We have declared this constant. Okay, constant int of button pin 1. Button pin 1 is D0, D1 and D2. It is connected to D0, D1 and D2, and D3, D4 and D5. LED is connected to D3, D4 and D5. So we have declared a variable button state 1, 2, 3, and okay, variables for reading the push button status, and setup, like setting this LED pin 1, pin 2, pin 3 as the output pin, and button pin 1, 2, 3 as the input pin. Okay, so the loop, the void loop, we are digital read. We just read this digital button pin 1, and then if the state is high, if it is high, we are writing this LED pin as high. If it is low, then we are writing LED pin 1 as low. Okay, digital read of button pin 2. Like if button state 2 is high, we are writing LED pin 2 is high, else it is low. Okay, for button pin 3, the same thing. So this is the example for switch and LED. Switch and LED. So today program, like we have got up LED blinking, switch and LED and UART. Okay. So with this I close the session. Thanks for coming and thank you for your time. And tomorrow session, like we'll be covering up how to like interfacing IoT, like how to send temperature data to the cloud using NodeMCU. Okay, how to send how to connect DHT11 sensors to NodeMCU, and how to send this data to the ThinkSpeak cloud. So that we will be covering up tomorrow.